Red FM and Mining Tomorrow. Each week we look at a different company, put them under the microscope a little bit. Today it's Alltech Chemicals Limited on the Australian Stock Exchange. ATC is the code. We've got their Managing Director and CEO, Iggy Tan, on the line at the moment. G'day, Iggy.
How are you?
Going well. Now, I'm going to be on a bit of a learning curve myself here. Your company is into high-purity alumina. Now, I guess a few others haven't heard of high-purity alumina before, so what is it? What's it used for? And what are the prices like for it? What do you sell it for?
Okay, well, in high-purity alumina is essentially aluminium oxide. It's the same material that Alcoa and Worsley produce down in the southwest, but they make a quality that's around 99.5%, but we make 99.99% purity alumina. And it's a very high purity material. It has less than 100 parts per million of impurities, and this is critical to make synthetic sapphire. Ian, you might know that carbon actually forms diamond in the Earth's crust.
Yes, yep.
Alumina actually forms sapphire, and sapphire, as you know, is the blue color.
Yes.
And the reason it's blue is because it's got impurities like iron and chromium that creates that blue color. Now, today, you might not know that mankind actually produces synthetic sapphire. So they make synthetic sapphire, and that material is actually on your watch face, camera lens on your iPhone, and different applications. And that's the reason you don't have any scratches on your watch anymore, because that essentially is sapphire crystal. And as you know, sapphire has a hardness index of 9. Diamond is a perfect 10. So nothing scratches that watch face anymore because it's synthetic sapphire. Now, we make high purity alumina. It sells for between $15,000 to $40,000 a ton. Very high value material. They buy this high purity alumina, they melt it at 2,000 degrees. It recreates the Earth's crust. It melts, and then they let it cool over 21 days, and it grows a single crystal of sapphire material. It looks like a big ice block. They core it out using diamond cores, slice it up into wafers, and these wafers are the building blocks of the LED industry. You know about LED?
Yes, yep.
Very efficient lighting system.
Yes.
It uses 1/6 the amount of electricity than normal lights, and it's essentially sweeping the world in lighting. And a great example is Optus Stadium in Perth. It's all LED lighting.
Yes.
So every LED has to have a sapphire wafer substrate. So you can imagine the growth going forward for high purity alumina in this sector. Now, the other sector that is driving the growth is in the lithium battery sector.
Righto.
So every lithium battery has high purity alumina in the separators to protect the battery safety, because if you remember with the Samsung Galaxy battery fires.
Yes, can't take them on the plane and all that. Yep.
Exactly. So if you have a positive and negative terminal in the battery and they touch, you have a contact, you have a thermal runaway, and you have a battery fire. And these batteries have separators that keep them from touching, and it allows the lithium ions to go back and forth. Now, as you know, our batteries are getting hotter and hotter because of the energy density we're packing into that volume. And these separators tend to shrink when the batteries get hot. But if they apply high purity alumina into these separators, it maintains these separators, and it's now critical for battery safety to have high purity alumina in these batteries. So the two industries that are driving the growth for high purity alumina are in the LED industry and the lithium battery industry.
Sounds like it's going to be highly disruptive technology. Would I be right?
Yes, the technology we're actually using is disruptive, because currently the way they produce high purity alumina is they use aluminium metal as a feedstock. Aluminium metal is a very expensive feedstock. Our process actually uses kaolin from Meckering in Western Australia.
Right.
Kaolin happens to have alumina in it, so we have a chemical process that extracts the alumina from the kaolin, which makes us highly disruptive and a third or half the cost of production as the current producer. We are building a 4,500 ton per annum plant. The capital cost is about $300 million US. The economics is very strong. It generates a net present value of $500 million US, and at its full rate, it generates around 76 million earnings before interest and tax per annum. So very high margin, high return project. And essentially, we ship our kaolin to Malaysia. We are in the process of building a chemical plant there, and that will then extract the alumina from the kaolin, producing a very pure alumina.
Beautiful. Now, you're into the final stages of funding for the project, is that correct?
Yes, so we have debts coming from a German bank called KfW IPEX Bank.
Yep.
That's about 190 million of senior debt has already been done. We have about 90 million of mezzanine debt coming from Macquarie Bank, and that's going through its due diligence process. And then we are also going to be raising about 100 million US from the European community via another company that we will own, a German entity, and we'll be raising that amount. Now, rather than wait for everything to finalize in the funding process, we're so confident with the project. We have raised something like 40 million in the last 2 years ourselves, and we have commenced the construction process in Malaysia. So in Malaysia, we've got a lot of the groundworks going, and we've started to build workshops and so on. So the idea is to run the construction process along the same times as the final funding stage. But the other area that is interesting is that we also have a very large German engineering company to build the plant. They will give us a fixed price turnkey contract. And as you know, that really negates the risk of capital cost blowouts and so on. And they will also give us a process and quality guarantee. So they will guarantee that the product that the plant produces will meet the final Mitsubishi specifications. Mitsubishi is our off-taker. We have a 10-year off-take with Mitsubishi. As you know, they're a trading house. They will buy our product, and then they will sell it to their customers in the LED and the lithium battery industries in Japan, Korea, and Taiwan. So off-take's done. The EPC contractor is now started the process. We have senior debt funding away. We are going to close with the mezzanine debt, and very exciting project. If you can think about the demand coming from those two industries, there is going to be a shortage. CRU, which is the research firm, recently did an analysis, and they believe there will be a shortage of 20,000 tons by 2028. So that's nearly 4 times our plan of shortage coming. So very exciting project.
Yes, and it sounds like you've got your plate full and all the timelines are in place. Really appreciate your time. Been speaking with Iggy Tan, Managing Director and CEO of Alltech Chemicals. They are on the stock exchange. Their code is ATC. Iggy, really appreciate the update and your time today.
Thank you very much, Ian.